Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems based on the concepts of vectors in R3. So let's start with the first problem. So given vector x plus vector y equals negative I plus 2j plus 5k and vector x minus vector y equals 3i plus 6j minus 7k, determine vectors x and y. So we have to find vectors x and y in terms of I, j and k using these two given equations for vectors x and y. So the first step is to rewrite these two given equations. So we have to solve these two equations to find the vector x and vector y. We can treat these two equations as a linear system, and we can use substitution or elimination method to solve these two vector equations. Now for these two equations, it will be easier to use the elimination method because the y vector has the coefficient 1 and one of them is plus 1, the other is negative 1. So if we add these two equations, the y vector term will get cancelled out. So x plus x will be equal to 2x. The y terms will get cancelled out. And on the other side of the equation, we can add the I, j and k terms. So for the I term, so negative 1 plus 3 is equal to 2. And 2 plus 6 is equal to 8. And 5 plus negative 7 is equal to negative 2. Now we can isolate x on the left side by dividing both sides by 2. Now on the right side, we'll divide each coefficient of these unit vectors by 2. So for the first unit vector I, we can do 2 divided by 2, which is equal to 1, but we don't write 1 as a coefficient, so we get just I. And then for j, we do 8 divided by 2, which is equal to 4. And then for k, we do negative 2 divided by 2, which is equal to negative 1, or we write just minus k. So this is the vector x in terms of I, j and k unit vectors. So this should be the final answer for vector x. Now we have to find vector y, and for that we can use this vector x that we just found and sub it in the first or the second equation and then solve for vector y. So for this problem we can use the first equation. So I'll sub in vector x as I plus 4j minus k in the first equation, plus vector y. So this is the equation we get after substituting x as I plus 4j minus k in the first equation. Now we have to isolate y. So for that we'll have to subtract I from both sides and subtract 4j and add k on both sides. So we are left with vector y equals, so this is the final answer for vector y. So we combine the I, j and k terms on the right side to get this final answer for vector y. So we are done with the first problem. Now we can analyze the second problem. So in the second problem, given the points A and B, determine each of the following. So let's start with part A. So in part A, we have to find the magnitude of vector OA. Now OA vector represents the position vector for point A. So first we have to find the position vector and then we'll find its magnitude. So position vector OA is equal to the given point A. So in position vector OA, O represents the origin. So there is a very important concept we need to understand and memorize for finding a position vector from the given point. Now we can find the magnitude of this position vector. So negative 2 square is 4, negative 6 square is 36, and 3 square is 9. Now we can add these numbers. So I get 49 and square root of 49 is 7. So this is the final answer for part A. So in part B, we have to find the magnitude of vector OB. So first we'll find vector OB. Vector OB is a position vector for point B. So vector OB is equal to the given point B. Now we can find its magnitude. So 3 square is 9, negative 4 square is 16, 12 square is 144. Now we can add these numbers. So 9 plus 16 plus 144 is equal to 169, and square root of 169 is equal to 13. So this is the final answer for part B. Now we can analyze part C. So in part C we have to find vector AB. So for that we should break down vector AB into its position vectors. So we get OB minus OA. Now position vector OB is equal to point B, and vector OA is equal to point A. Now we can subtract these two vectors. So we have to subtract their x, y, and z components. So for the x component, 3 minus negative 2 is equivalent to 3 plus 2. which is equal to 5. And then negative 4 minus negative 6 is equivalent to negative 4 plus 6, which is equal to 2. And 12 minus 3 is equal to 9. So this is vector AB, the final answer for part C. Now we can do part D. In part D, we have to find the magnitude of vector AB. So we'll use the vector we found in part C. So we should square the components, add them, and apply square root to the sum. So 5 square is equal to 25, 2 square is 4, and 9 square is 81. Now we can add these numbers. So I got 110, and square root of 110 is equal to almost 10.5. So this should be the final answer for part D. Now we can do part E. In part E, we have to find vector BA. So we can break down vector BA into its position vectors and then find vector BA. So it will be equal to OA minus OB. So vector OA is equal to the given point A, and vector OB is point B. Now we can subtract these vectors. So we have to subtract their x, y, and z components. The negative 2 minus 3 is negative 5 for the x component. Negative 6 minus negative 4 is equal to negative 2. And 3 minus 12 is equal to negative 9. So this is vector BA. Now we could have also found vector BA by applying a negative sign or multiplying vector AB by negative 1, because vector BA is opposite to vector AB. So that's the other way of finding vector BA. So now we can do part F. So we have to find the magnitude of this vector BA. So we can square the components, add them, and apply square root to the sum. The negative 5 square is 25, negative 2 square is 4, negative 9 square is 81. And their sum is equal to 110, and square root of 110 is almost 10.5. So this should be the final answer for part F. So the magnitude of vector BA will be equal to the magnitude of vector AB, because these vectors have opposite direction, but their magnitude will be the same. So these are the steps you have to keep in mind to solve this type of problem. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.